Hello, everybody. My name is Peter Salimo. I am the Director of Global Partnerships at Yugabyte, and I'd like to thank you for taking some time out of your day to learn a little bit about our database product, but mostly to learn about Anant and their open data platform Playbook. They're a new partner for Yugabyte, and we're very excited about this partnership. It's a programmatic approach that we've seen work over and over again, and it's something that's very critical to our business. We've got presenting here today, Rahul Singh, who is the CEO of Anant, and then also on my side from Yugabyte, we've got Andreas Markvoldus, who is a principal engineer, to take any of your technical questions. I'd like to open with a brief introduction about Yugabyte, and through that, I think you'll find where this partnership is headed and why it's such a good match together. It'll show you where we need to be working together and what our opportunity is. For those of you that don't know, Yugabyte is a cloud-native, distributed SQL and NoSQL database specifically for transactional applications. It is a relatively new product, started in 2016. It is 100% open source, and it is familiar and compatible with Postgres and Cassandra. The database itself will run anywhere. It will run on-prem in your existing data centers, on bare metal, will run on any cloud, whether it's public, private, or hybrid. And our definition of hybrid expands to both on-premises and in the cloud. You can run it inside or outside of containers. So if you use Docker or Kubernetes, it's fully compatible and controlled within those environments. And you have the option of managing and running it yourself in your own infrastructure, or allowing Yugabyte to provide that for you and having it run in our infrastructure. Just a brief snapshot of our company history. Our founders started out years ago as Oracle Oak Table engineers and moved together to Facebook, where they were responsible for a lot of Facebook's growth and also responsible for the development and open sourcing of both Cassandra and HBase. They saw that need, they filled that need, and then they moved over to Nutanix, where they worked on distributed systems, but recognized that there was still a gap. There was still the hardest problem that hadn't been solved in the database world. And in 2016, decided to go and tackle that problem. They formed Yugabyte as a company. We're now over 400 employees and global, very well-founded and well-funded, and have a roster of enterprise customers that is very enviable. And you'll see why in the slides coming up here. So where we fit in and the problem, that gap that we were addressing to solve, has really been fueled by the evolution of IT, the advancements to the modern, scalable, flexible cloud world. For decades, we've seen the evolution of the infrastructure layer as people moved to commodity hardware in the cloud on AWS and GCP and Azure. And we've also seen the advancement at the application layer with the advent of containers and app frameworks in Kubernetes and microservices. But the laggard in all of this has remained the database. For the most important mission-critical core transactional systems, those databases are still running on DB2 in the mainframe. They're still running on Oracle in a single monolithic database environment. And we set out to solve that need and fill that gap and create a modern database environment that could bring those legacy applications forward. So if we look at what's out there and what has evolved over the years, again, we go back to the legacy relational databases that have been around for decades, the Oracles, the DB2s of the world. They're very, very good at certain things. They provide consistent transactions, and that's critical for mission-critical transactional environments. They provide indexes and a comfortable and widely used relational model. But when you need to scale, they really fall down. That's where people have had to add on and bolt on features and functionality to do sharding and geodistribution and load balancing. And those are things that just weren't inherent in the traditional databases like Oracle, even single node Postgres and SQL Server. And that was really the reason for the birth of the non-relational databases. the Cassandras, the Mongos, and DataStack, the enterprise support for Cassandra. They were there to provide the scalability that was lacking in the traditional database systems, provide geodistribution and native replication with eventual consistency of data, but not data consistency. They really couldn't offer the same type of transaction consistency that a traditional relational database could. They didn't have indexes. You were writing an entirely new programming paradigm. They didn't have the relational database models. And a response to that was the birth of the cloud databases, those things that were offered by the cloud service providers that are trying to meet that need of providing ease of use, a more similar programming environment, more similar to SQL, providing some of the resilience that was lacking in the traditional database systems and some data consistency. But inherent in having a cloud provider create a database for you is you get locked into that cloud provider. They're not open source, and there are limitations on the high end and extreme costs on the high end with many of these products that our customers are trying to avoid. Thus the birth of Yugabyte. And what we've done is married the best of all worlds, where we provide a consistent relational environment of SQL, of PostgreSQL, immediate productivity for developers that know that environment. And similarly, we provide that same environment for Cassandra. We've taken the features of the non-relational databases and built in automatic resiliency, automatic scalability, and geodistribution. And we've future-proofed these environments. So it is fully open source. It is fully multi-cloud. It is fully hybrid cloud. And you can take any workload that is a transactional workload and run it within our platform. And I'll show you how we do that in the slide here. We've actually taken the concept of the database and split it into an upper and lower half. On the lower half, we've built out a distributed transaction storage layer that takes all of those things that were being bolted on to a traditional database, and it does them for you like a database should. It does automatic sharding. It does automatic load balancing. It manages distributed transactions and ensures that they meet ACID compliance. It has a raft consensus. And then on the upper half, the part that your applications and your developers interface with, we've built a pluggable query layer. So we have an entire query layer built with Postgres. I didn't say it's built like Postgres. It actually is Postgres. And our true Postgres compatibility is one of the primary reasons that you see the Fortune 50 customers on our account list. We have stored procedures, we have triggers, we have indexes. We can take a Postgres application because it actually is the Postgres query layer that's built into our database. Similarly, we have a Cassandra query layer. If you have a Cassandra or a DataStax application, it marries into our database very readily. And you'll see more APIs coming down the road. But a database by itself needs to run on an environment. And as I mentioned before, you can run this on-prem, you can run it on bare metal, you can run it on AWS, GCP, Azure, in or outside of containers, and you can run a database across all of those. You should have that flexibility, and it's what we're here to offer. And it needs to plug into your overall environment and fit well and play well with everything else that you have available to you in your stack, whether that is in existence today or whether it's something that's going to be adopted as you move into a more modern application architecture. And that's really what Anant is here to talk about today. So if we drill in and look at what does Yugabyte really offer, why do our customers buy our database product, use our open source database, use our services? It's really about resilience and continuous availability. Zero downtime should be the standard, and it is the standard. You want to be able to survive failures, you want to be able to survive outages, you want to be able to do upgrades without interrupting your service and without losing any data. You need the flexibility to have massive, rapid horizontal scale. Grow your workload, just add nodes and rebalance the data and have that happen automatically. Move to billions of operations per day, hundreds of terabytes. Rapidly scale queries so that you can meet service requirements. If you're a retailer, before Black Friday, spin it up. And then after the retail demand decreases, spin it back down. Use the right amount of infrastructure for the need. And then provide productivity to developers. Don't make them learn an entirely new development environment. When you've got Postgres or SQL available, give that to them. Let them take advantage of everything that Postgres has to offer. And this is something that's unique to Yugabyte is true Postgres compatibility. If you have stored procedures and triggers in your existing application, bring them forward and use them. And be ready for those failures. You may not have experienced a failure yourself, but you will. And our customers have. And they've hummed right along without data loss, without interruption. Cloud failures are a fact of life. And the more you have in the cloud, the more you're exposed to these failures. And your database should be able to accommodate for those and heal itself from those because they're going to happen. And provide some flexibility in order to make sure that you have that zero downtime and that zero data loss. I'm happy to say Yugabyte is the only database out there, the cloud native distributed database that offers both asynchronous and synchronous replication schemes. And something that our customers find extremely valuable. And where they're using the database are in three primary areas. Most of the use cases to date are around database modernization and replacing legacy databases and moving applications into the cloud and into a cloud native world, even if they start out doing that on premises. There are also greenfield applications that are born in the cloud, applications being written with microservices out of the gate. They're brand new and they're starting in that flexible cloud native world that we offer. And then lastly, edge and streaming applications. We're seeing a lot of uptick around IoT and taking advantage of some of our geo-distribution capabilities and the ability to put data where it belongs, move it to the edge, follow GDPR regulations and keep data out of places it shouldn't be. And make sure that you're getting the performance where you need it, when you need it. And you can see that we've got a very impressive array of customers. Anybody that's got an OnStar button in their General Motors car is using a Yugabyte database. Anybody that logs into charlesschwab.com is using a Yugabyte database. And that's because of the environment that we've built and the capability that we have to take legacy environments and take new applications and provide the best database available for them. Now, a database in and of itself, we're very proud of ours. It's critically important, but it is of no value without data coming into it, data moving out of it, and applications that can access it, and the ability to get from where you are to where you want to go. And that is why Anant's Open Data Platform Playbook and that repeatable and proven approach is so critical to Yugabyte as a company and to our customers. It gives a path to follow and a way to get from point A to point B, whether you've got a legacy environment that you're trying to move forward or whether you've got a brand new application that you're trying to build. With that, I'd like to turn it over to Rahul, and we'll be ready at the end for questions and answers. Oh, you are on mute. There you go.
I was talking to my buddy, Mute. I've gotten to know him really well over the last couple of years. Thank you, Peter, for getting us started. And what you ended with is that the best database in the world. If you don't have any means to get data in or get data out quickly, it becomes a much bigger challenge. And so then it becomes a modernization challenge, or it becomes a data migration challenge. And what we've seen is that the best way to use better technologies is to have a playbook to understand how technology changes. And that's the thing about the modern world today. The concept of an open data platform, it's relatively new, but I really began in the Hadoop world where people took the white papers, Doug Cutting took the white papers from Google and started to write code to basically approximate it. And now there's so many different tools and technologies, including, as you said, Cassandra started out open source, Yugabyte is open source. And these are enterprise grade software. They're ready to go. But the challenge is, how do you bring it all together? So that's what I'm going to talk about today. Thank you for having me, Peter, and Yugabyte. Really appreciate the partnership. And looking forward to making some waves. Give Google a second. Yeah, so today we're going to talk about transforming into this open data platform, if you're not already there, or if you're not already on the path to that. And to do that, how do you craft this stack of components essentially, so that it's good now, and you have the processes to keep it good, to keep it relevant for your team, relevant for your customers. And ultimately, that's what business is about, right? Staying relevant to the customers and staying relevant for the people that are working in the business. And essentially, we're going to cover some part of the design process that we use, that we've been using for a while. A little glimpse at the framework, basically, how we choose the tools in an open data platform. Why we make it a part of a framework, and how we structure it. And this is something you can borrow from either the design methodology or the framework methodology. You can just lift and shift it and start to use it. It's really not that difficult. It's just about doing it in a disciplined manner that brings the successes that we see. And then finally, the approach to managing a platform after you have built it. Getting the system up and running, rockstar databases, data in and out. What happens when your team member leaves? That's one of the biggest challenges in the business, right? People. And we have to think about that. We have to think about how to manage platforms when people cycle through. I was trying to cover 3 use cases today, but it would have been a very long presentation. So what I decided was we're going to cover two of the use cases, primarily, the standard data fabric, and that's a pattern that you can employ with open data tools. And then also, how do you choose between Google or AWS services versus open data, right? Peter was talking about these databases like Aurora or Google Span or Bigtable. These are available, but what is it about the cloud, public cloud native services and the open data platforms? Where do they meet? Because it's not always going to be one way or the other, right? There's always going to be some element of a company's strategy to say, oh, we're going to use as much of a particular cloud as possible. And even with that mandate, I think it's possible to introduce open data tools because they're just better in many cases, because these companies created these services and they haven't innovated. They've just been stuck in time as far as the features that they came out with initially. Our company helps people build global platforms. For customers, they want everything right now. It's Black Friday, but they want it 365 days a year. And the way we do it is we have this playbook with obviously what I'm going to talk about today, but essentially it's how you design, build, and manage platforms. And so that you can take the challenges of building platforms and rely on a process. And when you can rely on a process, your mental capacity can then focus on innovation, thinking, and growing big. We worked with quite a number of companies, and just by virtue of being in the distributed data world, the clients are fairly self-selecting. The customer experiences need to be real time. The data and analytics needs to be real time. So we work with these. We have the pleasure and privilege to work with these clients because they have challenges at a global level, and that's the kind of the problems we like solving. What kind of challenges am I talking about here? There's business challenges. There are business challenges then turn into platform challenges. We then have technology challenges that platform owners will have a good design, but they'll run into some technology problems. And then finally, once a platform is up and running, they have management challenges. So we have a playbook to help design. We have a framework to help essentially implement a platform, and then we have an approach to manage it so that your team can be as smoothly run as some of these as a service providers. That's kind of the goal, right? To create a scalable service within your organization that more and more customers, internal or external, could be using and tapping into. Modern technology is disconnected. It's just, it started out with, the internet, and it used to be you just install software on your computer and everything was fine. But as people started releasing software as an API, as a website, the integration problem that we had before became even harder, right? And users, you can ask anybody that works in a modern company, right? They're switching between apps all the time. And this is what we try to chase for our customers is ultimately your user, what do they need? And most people, whether you're using a consumer-facing e-commerce application or you're using an internal knowledge portal, ultimately people are trying to do one of three things: trying to find something, trying to analyze it, understand it, and they're trying to act on it, make a decision and act on it. And the quicker we can get people to do that, the better. All business platforms are made up of essentially 5 categories of platforms. Gartner put this graphic out in 2016. I love it. It explains the complexities of running a modern business. There's partner ecosystems, customer experience systems, information systems, IoT systems. But in the middle, we have data and analytics. And as you can imagine, all of these systems that are out there, they all have APIs. They're all changing. And then you have to make a decision. How are we going to bring all this stuff together? How are we going to integrate it? And if it's that important to your business that it connects and taps in different systems together for your company's efficiency, you probably want to make some good decisions on your design. Oops. So one of the other kind of concepts we try to think about is, this idea of enterprise consciousness. I'm going to turn off my video so we can be a little bit more smoother here. Sorry about that. And there we go. Start. I apologize, folks. There we go. I was noticing some connection lag, so I switched over. Going back to what I was saying, we have this concept of enterprise consciousness, and it's an idea that just like an application should be able to scale, a business should be able to scale. And just like a user has an amazing customer experience on a consumer website, the user experience for everybody should be as good as possible, not just for customers, but also for internal users. And that requires a lot of work because internal software are legion. There's so many different tools that are out there, right? How do we make it all work together? We're going to look at that later, but we go deeper into just data platforms, right? Forget about integrating CRM systems and CMS systems. Let's just talk about data in general, right? Most businesses have seen the basic, challenge of going from being siloed to essentially starting to standardize their technology, right? And the biggest, deepest challenge that they have is going from, the standardized technology to having an optimized core with standardized processes and standardized data. That challenge is where it gets most people. Now, if they can cross that and get to the other side, that's when they can reap the rewards of business modularity, growth, to be able to acquire companies and integrate them into their business, partner with other companies and do joint ventures better, right? So technology is strategy, right? Which company is not an IT company today, right? And this is another example, right? You have all these apps, you standardize on, let's say, containers to run your custom code. Then you decide, okay, we're going to standardize on the database. Well, that's where a database like Yugabyte comes in. It can solve a few problems in one platform where you would normally have to maybe go to different technologies. And it basically gets you to business modularity a little bit sooner. but it's not about just the database, right? The data platform has different needs for different businesses, but generally they have a data warehouse, they have a relational database, they have a document database, they have a white column database, they have a graph database. The point I'm making is that no one business is actually the same. They're not all going to be able to use the same product. And just like a piece of software that you would download, like Gigabyte, needs to be customized, think about your whole data platform as a piece of software and how it needs to be customized for your business's needs. And what helps us think bigger than the traditional data systems is that technology has become such that it gives us power. So we're going to talk about Gigabyte, but this idea of cross data center replication, it was really made possible by Cassandra, right? Cassandra brought this concept. There are other databases that use it, but it does it pretty well. And when we can distribute data across different data centers, we can do amazing things with data processing. We can bring data into one data center and let another data center do reports. We can have a data center where we are powering our APIs while at the same time we're running machine learning processes. This was not common with the relational world because it would tap out at the transactional layer, let alone try to do transactions and analytics at the same time, right? They have to have a different OLAP database to do analytics. Now, because there are tools like Apache Spark, Presto, right? We're able to talk to any database and do analytical queries, machine learning, as well as federated queries across databases. This technology, yes, you can buy it, but the open source stuff is pretty good. In a data platform, we start out with the design. Why do we need it? Why do we need a data platform in the first place? So in our company, we call it the Modern Enterprise Canvas, but basically we have these contexts matrixed with the responsibilities, and we have an approach to understanding, inventorying it, but also understanding the goals of our customers. We have a framework to help us choose from. So we're not, you'll see exactly why we need a framework. And then we have tools. We have templates, we have automations in place, and these continue to get better because we don't want to reinvent the wheel, right? If we can do something, or sorry, if a robot can do something, why should we? You can go look for reference architectures, specifically open data reference architectures, and you're going to come across a lot of different cool diagrams. I love these diagrams. I save them. I geek out over them. I'm always looking for better ways to make my diagrams, so I love them. But think about it if you're trying to make your platform. Which diagram do you choose to use, right? And that's, again, one person's concept of a data platform may not necessarily be your saving grace. And this is why in our playbook, we don't say, here's what you use. We're telling you how to choose what you need. Because in the data landscape, this is just the Linux Foundation's open data components, right? These are open tools out there. And this is First Mark Capital's chart of, this is 2 years old, by the way, the First Mark Capital one, right? These are software just in the data and AI world. This is not marketing software. It's not, this is just data and AI. And open source is just one layer. But think about this, like H2O, right? This is such a big diagram, and H2O being such a big player is still only one little logo in this canvas. And this is the challenge why, this is literally the challenge why we needed to have a framework. We didn't want to go through this paralysis of choice every single time we're trying to solve our clients' problems. So we go through an inventory process. People, process, information, and systems. And in our evaluation framework, we have components in certain categories that we know work well together. We know there are tools for ELT, ETL, ETLT, and even reverse ETL that work well with distributed data. That's generally what we work with. And not only do they work well with distributed data, they're open source. Right, so we've gone through the trouble of understanding what of these puzzle pieces actually fit together out of the box, or how much work is involved to make them connect together. And then it's a matter of execution, right? Design, you've got a concept, but then you have to go in deeper into the technical design. Once you have a technical design, hopefully you're not doing too much programming or scripting. It's more configuration. We want people to do more clicks, not code, like Salesforce does. The less code you write, the better, right? Let the robots do this. And then finally, operations. How do we continuously set up systems in a repeatable fashion? How do we deploy things? How do we manage and monitor things? These are all parts of the bigger picture. And of course, if it's a mission critical, business critical platform, we need to have these processes in place. So our modern canvas, enterprise canvas started out with, when we take a look at a company, right? How does the company work? Who are the people in a particular, let's say, responsibility area? In this case, products and services, or in research and development. And which of these processes connect with other responsibility areas? And when we go one level deeper, we see, hey, some of these processes, they share information. And if you go down one level deeper, you may see that they share systems, but a lot of times you realize that they're just using different tools. Every one of these teams they're using different tools, and not because they don't want to make the CIO's job easier. It's just somebody said, hey, have you tried this tool? And they go sign up for it. Right? Shadow IT, big problem. When we apply this deeper into a data platform design, we're asking slightly different questions. Who are the customers of the data platform? Who are the business owners of this data platform? How is it getting engineered and configured on an ongoing basis? Who operates this platform? And we think about them as actual people that are interacting with the platform. We empathize with them and say, what are they trying to do? What are their goals? What information do they need to work with? Right? What systems are they interacting with? And when you start to look at it, there's a lot of patterns that we can see when we compare people and their processes, but the patterns are really in the information layer. We don't really care about systems being different. If the information is same, there's a challenge there to synchronize information, right? If the business processes require us to move information from one system to the other, it's okay for companies to have different systems. That's okay. That's what's going to happen, right? Everybody wants to use whatever they want to use. But we have to see the pattern. How do these things connect together? And once we have an idea of how these things connect together, that's when we can bring in a framework. And a framework for us is made up of tools that are distributed, real-time, extendable or open, automated, monitored and managed. And the reason we pick these is that when you're building large-scale platforms, ultimately, if it's not one of these things or can't be one of these things, it's going to fall over. But you may ask, well, why don't I just use everything from Amazon? Right? Here's an example of a workflow we designed a long time ago, using complete serverless functions with streams managed by. Why wouldn't we go with this to market? Right? Let's ask that question for another cloud. Here's an Azure design, 100% on Azure, everything that Azure has to offer. Why should we go with this? Why shouldn't we go with this? That's really the bigger question, right? And of course, we can't leave out Google, right? They started the big data movement. We got to have them somewhere in our deck. Why would we not just go with these ready to go? Here's everything for you. And that's really the discussion about how do we optimize what the cloud gives us with what open technologies, open core technologies give us, right? You have the ability to do Postgres on every cloud. They have some Postgres as a service. But what if you wanted to have data synchronized between these three clouds, right? That's where Yugabyte can solve that problem overnight. The other thing that people face is once they go from a relational database, a monolithic database, they go to a distributed platform. there are a lot of moving pieces. And if you get super bought into one cloud, there's really small chance you're going to be able to move off of them at some point, right? So thinking about your current needs and also asking yourself, hey, is Amazon going to enter my market, right? Do I have to move off of Amazon to Azure because they're going to come into our market and do what we're doing? Open data, open distributed tools allow us the freedom to go where we want to go. Sure, there are technologies that are being created by Google and Azure and Amazon. They do a good job, sure, but they don't give you the freedom of being able to move out. And at the same time, there may be legacy systems that people use that they don't want to move off of. So how do you bridge this gap between open data, open core, and cloud native? And then there's another class of software that's recent, I would say in the last 5 to 10 years, is we have really good movement in the database world, the data processing world, the stream processing. But recently, there's a whole family of open tools, open data platform tools that are enterprise grade in their category of, let's say, a data catalog. You have to pay Informatica huge amounts of money to get your own data catalog, or Elation, right? It's ridiculous. Now you can go get Amundsen, which is open source, right? You have to pay a company large amounts of money just to have something scheduled jobs for you, ETL jobs for you. Now you can go get Apache Airflow, right? And I can go on and on and on, but it's not just technical tools like a data catalog and a scheduler. There are low code, no code tools to get data in very, very easily and send data back out to your upstream systems very easily. And we'll see a picture of that. So Grouperoo, Airbyte, and Rudderstock are just 3 examples of a whole family of software now that's available, that's open. Click, 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 get data into a database, right? And then there are specialized databases that, for example, will approximate that app for a customer data platform like Segment. You don't have to pay Segment anymore. You can use I think it's Post-Hoc. It's like a Segment clone. And of course, there's BI tools. Lots and lots of tools. You see this common thread of grids in my decks. That's really the best way to compare these things together. You have to categorize them. You have to put them as close as possible. You sort them in a way, say, okay, I can understand there's an open source strategy we could use. And I can understand that there are a lot of streams and queue technologies available. What do I use? Well, you can go completely open source. You can go completely AWS. But our recommendation is you use what is the best in that technology area. And open source technologies supported by commercial companies, they tend to give you not only the best innovation, they also give you the best freedom going forward. And of all the tools that are out there, you need to pick the right ones and plug them into this. This is just it's a sample framework, but what I'm trying to show here is that there's a lot of DevOps tools and data ops tools that can go around your data choices that you don't have to think about anymore because they just work really well. So you've got a data platform. Finally, you need to be able to manage it. And the approach we take is every tool, every platform, we should have one page that has how you set it up, how do you get people trained on it, what are the administration processes, how do you do it, what are the configuration processes, how do you do it, and then where's the rest of the system, where the code is, where the configuration management is, right? And it's really that simple. We start with that, but it can become a little bit more complex. We have a simple schema. People ask, why did you come up with this? We already have TOGAF, we already have ITIL. Well, TOGAF and ITIL, very few people understand what that is, but it's easy to remember stack, right? Setup, train, administer, configure, and knowledge management. And you know what? Once people understand the acronym, they don't have to know every single one of these potential things they can put in there. It's a starting point. And that starting point is what allows new team members to get involved. Here's a deeper stack outline where you start off with just for the whole platform, but then you go to each layer, infrastructure, compute, data, and how's the cloud set up? How do we administer the cloud? How's Gigabyte set up, right? How's DataStax set up? The point I'm making here is that no matter what you do, a complex system is going to arise in your organization if you're dealing with any type of, weight of information. So how do you choose to organize this? Well, we're giving you a simple schema. I think it works pretty well. I think it works with most people pretty well. And I know I'm going a little bit over, but I can't leave you guys without giving you this potential future, a standard data fabric with open technologies. Coming back to the Cassandra cluster idea, right? Cassandra gave us this idea that you could put data one place and it synchronizes to another place magically across the world, across regions, across logical data centers. That's a really cool concept when you want to make a data fabric. But when you apply the same concepts to Gigabyte, it's like that cubed. It's that to the third power, the 10th power, because now we're not just able to do things with CQL, we're able to do things with SQL. And that changes everything. Because of all the tools that are out there for ETL, ELT, no code, low code, most of them, they work with SQL really, really well, right? But if you have to do CQL, so sometimes you have to have a little shiv to connect it together, and you can get it to work. Of course, you can always program all this connectivity, getting data in, but with technologies like Airbyte, and Fivetran is a commercial software, but like Airbyte is an open source software, commercial grade, or even something like RudderStack, right? You can get data in by just saying, I want my data from here to go here. You've got it in the system. You want to analyze it, great. Do it in a different, well, in Gigabyte, we call it a cluster, right? You do it in a different cluster. You want to serve it up? Sure. Hasura, which works with Postgres, can be applied to another cluster just to do APIs, GraphQL APIs, or Postgres, which is a, again, open source tool that works with Postgres. You can just latch that on and get ready-made APIs on top of your Postgres databases. And once you like your information, once you've processed your information, you can send it back. This was so tough before. Now, again, Grouparoo is actually a part of Airbyte now. RudderStack is also another free one that does both ETL and reverse ETL. Imagine being able to bring Salesforce and HubSpot data together, do some deduping on your own, and there's probably some software that's out there that does it for you. And once you're happy with it, you can sync it back to Salesforce and HubSpot with the correct information, all with open software. And the way we're able to come up with a picture like this is because we take the process of what are we trying to do, for whom, what are the tools that are out there that are open, that work well together. And of course, when we build it, we have to manage it. And that mindset that, hey, somebody has to operate it, helps us choose software that is easier to use, software that is clicks, not code. Key takeaways: don't reinvent the wheel. Do a little bit of research, or you can obviously work with us, but don't reinvent the wheel. There's a lot of tools and technologies out there that may have already solved your problem. Identify specific objectives. What is it that your current platform needs to do today? Or what is it falling behind on? Or what do you anticipate in the future? Right? Don't just go for a tool or technology because it sounds cool or it is cool. You use something that's going to solve a problem for you. So what is your objective? What's your goal? What's your mission? And then prioritize DevOps and DataOps. This is the single most important factor in agile teams, is that when they promise a feature, they can ship that feature. Well, if you don't have automatic deployment, automatic build, configuration management, and you don't have scheduling software, then you can't ship features as fast. Using open tools that are supported. And I'm being very clear about that. There's tons of open source software that nobody supports anymore. And it's not wise. We've made that mistake. Oh, we'll take over this open source project and we're going to work on it. Yeah, okay, right. Unless you're Apple and Walmart, you don't have the resources to do it. And finally, document the stack. Build your platform, but document it so the next person in line can come and help. If you liked what you saw today, work with us. And I believe we have some time for some questions.
We do, Rahul. Thank you so much. Just from what we've seen from our customers, what we've seen in the field, what we see from people that want to get going. It's so good to see the years of experience and lumps and bumps and pain that you've gone through to be able to develop this programmatic approach and get through the analysis paralysis. I mean, be able to do that discovery and figure out what is existing and what does the path look like to get where I need to go, and know that you've got the stack process on the back end to build the foundation, that it's not going to crumble once you've gotten to your initial goal, and you can continue to grow and scale. It's something I see as incredibly valuable and, in fact, mandatory for being able to modernize your environment. We do have a few questions, and first one that I see, Andreas, is a technical question, and it's for Yugabyte, and we want to know what's available for migration from existing systems. What kind of tooling is there? How do you get from Oracle to a cloud native? I know I need to get off Oracle. How do I get to a cloud native distributed transactional platform like Yugabyte?
That's a great question, because migration is everybody's always migrating off of something, especially nowadays. The good news is that Postgres, we're utilizing the top half layer of Postgres, and there's already a lot of existing tools out there that help migrate from Oracle to Postgres, so you can leverage those. Additionally, we've done quite a bit of work, and we've recently introduced a framework called Voyager that helps take schemas that are in Oracle and easily migrate them to Yugabyte. So not only is there a rich ecosystem of tools out there for Postgres, Yugabyte as an organization, we're developing tools that help customers migrate, in this particular case, Oracle, but there's a lot more other systems that are going to be coming online that we can leverage this framework that we built to utilize in migrating from your existing system into Yugabyte.
Yeah,
Thank you.
And Peter, I want to add to that. There's one kind of challenge of moving from a Postgres or an Oracle to the Yugabyte Postgres layer, but there's also sometimes tools that are available for migrating Cassandra data, right? And we found that there's at least 3 open source tools that are out there made by different database vendors, basically, they're very agnostic. They just talk Cassandra, and you can move from one Cassandra to a Yugabyte, or it doesn't matter because it's using CQL. And those alone are not going to do the whole migration for you. There's always some other thing that we have to think about, and it's stuff like Airflow that can help, right? We have to redo this just to test it, for example. And it's over and over and over again. I see this basic need for having automation in your mindset that, hey, if a robot can do it, let's get the robot to do it. That's what's going to be successful in the long term.
Yeah, that makes perfect sense. Next question is for you, Rahul. What are the biggest drawbacks of using a public cloud native offering versus one that is open core?
Yes. So, this question has come up at different companies for us, and it's either, hey, why not Dynamo, right? Why not Cosmos? Why not Spanner? And at least I can rule out Dynamo pretty quickly, which is they haven't really changed in what they do, right? It hasn't really improved, and there are just better ways to store documents. You can store documents in Yugabyte. You can store documents in Cassandra. And that's my one gripe about AWS, is that when something works for them and it makes money for them, they stop innovating. And they may improve it a little bit, but They're Amazon, right? They don't need to do anything. When we talk about Spanner and Cosmos, which are cloud native databases, that's where there's an insight. Why did Microsoft decide to do a CQL layer, right? It's because the ideas in the original, Cassandra, and which we're also using in Yugabyte, they're timeless. But if you think about the costs associated with Cosmos to get the same performance as open core, it's like night and day. It's just ridiculous how expensive it could be. If you're doing analytics on it, they used to have only one price, and now they have two prices, one for transactions and one for analytics. But anytime you have to read the data, you're going to be paying a cost. So those databases can rack up some pretty heavy bills. Dynamo, for example, there's tons of gotchas, and you have no control over it because you can't monitor it properly, right? That's one of the caveats that we have. If you can't monitor it at a deep layer, then you're missing out on potential scale issues and solving scale issues in the future. So not being able to go deep in monitoring and debugging, sometimes if you're not a big enough customer for these big clouds, you don't get the support you need. It's just like that's it, right? And the other is cost. So those are my reasons. There's probably other reasons that I have, but just at the top of my head, I would say those. There's a question from somebody here. How can Yugabyte transform the 5G industry? I'm going to shoot that to Andreas.
Yeah, I think you touched on a lot of it in your presentation, Rahul, where you talk about the openness and flexibility with all the tooling. I touched on it a little bit with some of the geodistribution and being able to push data where it needs to be, and then the automatic recovery. But Andreas, I'll let you comment a little bit more on that.
Well, I mean, I guess it depends on a couple factors, but Yugabyte in essence is it's a distributed data fabric, and if you think about 5G, the networks and things like that, it's all about data locality, connectivity to the customer, and having the ability to bring that fabric and that data locality closer to the user via an application. And because of Yugabyte's architecture, really the limiting factor in some ways is actually network latency. You can have machines that are distributed in an availability zone at a regional level or even at a global level. Additionally, because of security requirements, government regulations, you sometimes have to pin certain data in certain localities. Yugabyte provides a framework that you can easily leverage via both a Cassandra as well as a Postgres API and achieve that fabric so that your applications can deliver a much better end user experience.
Great. We've got another question from one of the participants here. I'm going to send it to you first, Rahul, and then Andreas, I'll ask you to comment as a follow-up. How can we trust the security on open source platforms, or should we focus on security in DevOps, like following DevSecOps? And as just a quick response on the Yugabyte side, one of the things that our customers, we do have security built in. We can go into great detail about that, but exactly where we are. One of the things that a lot of our customers are Fortune 50 customers have found very reassuring is the ability to run on-prem behind their firewalls in their data centers, and then gradually move components to the cloud as they're more comfortable, or keep some of them on-prem forever, where they have more control over that security environment. But in the broader picture, Rahul, I mean, it's mind-boggling how many tools and systems are out there that you guys are keeping track of. So security clearly is a question that needs to be addressed, and it's part of your approach. So I'll ask you to respond to that as well.
Sure. So developing secure platforms, it has a lot of policy processes that can help make that happen, right? So It's how you train your employees for how they, it's important, right? How they write code, right? You can have a secure database, but if your application doesn't do proper authentication and authorization, or doesn't do, multi-factor authentication, somebody could get a password and elevate their privileges through an injection attack and become an administrator. It has nothing to do with the security of the database software. It's the security of your application, right? So open source is has this other kind of conversation of like, well, when many eyes look at it, it can help resolve bugs, and that's really true, right? You can look at all the CVs that come out, right? Everybody contributes to help solve those problems. And if it's open source, somebody can just give back an answer to say, I fixed this already, here you go, right? You can crowdsource that. But it doesn't solve the inherent, what's outside of it. And that's really coming from just experience in seeing some like governments and banks and how they work, right? We learn a lot from our clients. We're not experts because we learned everything by ourselves. We're experts because we try to learn from other people and bring together the ideas that we see are good. And a lot of these ideas come from other people. But what we see in the government and what we see in large organizations and let's say the finance world is that they have strict controls related to source control. They have strict controls related to how data is stored in their database. Can a certain type of information be stored there in the first place? Right? In a test or dev environment, can I have customer information? And so it goes beyond just the database or the software security. I think to make it work well, I think the question was DevOps or DevSecOps, it's a starting point. And if you can put those in place and then inform your team to get around the security bandwagon, that's really how you're going to secure software. Airflow had a big vulnerability, right? What was the vulnerability? Vulnerability was it had no password set up in the initial configuration. Well, that's security 101. Configure security on your software. Like if your database has authentication and you don't set up the security, of course you're going to get hacked, right?
Yeah.
Sorry, I went a little off. There's a couple of other questions on here that are interesting. What are features to enhance in Yugabyte compared to other cloud providers? I would say that I'm going to rephrase it. What are features that are better in Yugabyte compared to other cloud providers? And then there's maybe that's one question. Then there's another question.
So I'll go ahead and take that. I do want to just touch briefly on the security issue because it's actually a very important, and it's actually a topic unto itself. Yugabyte is actually a cloud. It's built as a cloud native platform, and we take security very seriously. And we view it as a joint partnership between us providing you the tools to manage the security. It's the responsibility of the end user. We're going through, we have a large number of certifications. We still have certifications in the pipeline that are on our roadmap to achieve. But the nice thing about it is that, it sometimes starts with the infrastructure. And because we can exist in a private cloud, public cloud, hybrid cloud, on-premise, we could leverage a lot of the existing systems out there or plug and bolt into systems that are existing that people might be more familiar with in cloud environments. But it's really a joint partnership. The feature that I would say that is really kind of, at least in my opinion, that differentiates Yugabyte from some of the other cloud providers is that it's cloud agnostic, for one. You could really run it anywhere. But I think of it as solving an important problem in the sense of if you need to have an active architecture, I almost feel that Yugabyte, there's just no other solution out there that can do it in an agnostic way. Asynchronous replication is very different than synchronous replication. Eventual consistency is very different than strong ACID compliance. And Yugabyte out of the box gives you that strong synchronous replicated data fabric with ACID properties right out of the box, and can be deployed anywhere on anything. And it's really, I think, the driving unique feature of the product. And then secondly, I know we're almost, I think we're at time, is that Yugabyte was developed kind of from an engineer's perspective. Our founders from Facebook, when they wrote something, they actually had to support it. So we are really big on infrastructure as a code, having REST APIs and things like that that can manage the systems from a programmatic perspective, and it gives you the ability to scale very quickly. So I know we're at time. I don't know if we can go over. I'll leave that up to Peter.
Yeah, final
and the
comment
team.
on that question is that one of the things and trends that we're seeing more and more is that larger customers, larger companies they have a mandate to have more than one cloud provider, just due to business environments, contract changes, and disaster recovery and failures and outages. So you may have and egress costs from those cloud providers. You want to be able to run your data and run your applications where it makes the most sense from a technology, a resilience, and a cost perspective. And Yugabyte brings that to the table, where the native core cloud provider databases just can't and won't ever do that. So we are at time. Rahul, if there are any closing comments, you're on mute at the moment, but I want to thank everybody who attended. Rahul, thank you so much for that really insightful presentation. Andreas, thank you for fielding the technical questions. And that's the end of my bit.
Thank you, everyone.
Yeah, just wanted to say thanks. Thank you both for being a part of this. This is great. Had a lot of fun.
Same.
Take care, everybody.
Everybody.
All right. Bye-bye.